So the question is there really such a thing as single-phase electrical service? You hear it all the time. It's everywhere. Single phase, this and that. But I don't think it's true. So I'd like to talk about my electrical ideas and see if we can prove that the thing called single-phase service isn't really a thing, okay? Please bear with me. This is very simple. You probably already know this stuff, but I want to review it for those who don't know anything about electricity, okay? So here's an AC generator. That's this big thing somewhere that makes electricity, and they pipe it into your house through wires and such. You can find all this information on the internet. So I'll just jump to the important stuff that pertains to my new theories, okay? So here's your generator. And inside the generator, a loop of conductor spins around, round, around, around, all right, many times. And electricity is generated. Okay, so this thing here, this little generator thing, spins at 60 revolutions per second. That would be 3,600 revolutions per minute. So 1 revolution is equal to 1 cycle, okay? 1 complete revolution here from 0 degrees all the way around to 360 would be 1 cycle. Okay, so the system we use here in the United States is a system of 60 hertz, they call it. 1 hertz equal 1 cycle per second. So if you look at this diagram here, all right, you would figure out that 1 cycle, 1 rotation would be equal to 1/60th of a second. In other words, that loop of conductor inside there goes around, all right? It goes around like this 60 times per second. That's pretty fast, all right? Now, if you want to see what's going on in there, figuratively speaking, you would take an oscilloscope, an electronic test instrument, and you could create kind of a picture of what's happening inside that generator. Okay, it's just an idea. It's not a real thing. It's just a graphic interpretation of what's happening inside there. All right? So here you have a cycle graph, or you could call it a revolution graph. All right? And this is 1 revolution in that generator. Here is your amplitude, and here's your time factor here. Okay, it goes this way. Time, amplitude. All right? Now, I'm not going to get real technical here because you can do this on the internet. You can find all that technical crap. I'm trying to show you that some terms are used and they kind of shouldn't be used. All right? Now, here you have the cycle graph. All right? And you see it goes up and it goes down, and you have 2 halves. You have a positive half cycle, right? That's this part here, and you have a negative half cycle. You see, if this is 1 cycle, all right, then this would be a half, and this is a half. This is very simple. Professionals will say, oh, this guy's a dummy. This is so simple. Everybody knows this. Up here would be your north polarity, and down here would be your south. In other words, on your generator, inside there is a magnet, and the north pole of the magnet would be situated here, and the south pole would be here. And this is a very primitive drawing, but I think you'll get the point by the time I'm done. So that thing spins around, all right, like this. And when it does, when it gets up to the north pole here, electrons are drawn to the north pole. They're drawn to it. When it gets to the south pole, when that rotating loop inside that generator gets toward the south pole there, it pushes the electrons away, right? So what happens is you have current flowing in one direction, then you get to this point here, and it goes back and flows in the other direction. That's a very simple concept, and you can study it on the internet. People will explain this in detail, but for the sake of this video, it's not necessary. So what you have is let's say this is one single conductor, all right? And this is the insulation here, the heavy blue line. And this is representing 1/120th of a second. You see, it's representing 1/2 cycle, either this or this. Okay, that's 1/120th of a second. So you see, during phase A, one of the half cycles, the current goes this way, then it gets to phase B and it goes that way. And this happens all in 1/120th of a second. Okay? And that's why we call it alternating current. So you have one cycle, all right, is equal to the positive half cycle plus the negative half cycle. That's this, what I showed you. The positive half cycle plus the negative half cycle makes one full cycle. Okay, that's pretty simple. But most people would refer to this as phase A. Okay, phase A is a part, it's an action part. And phase B, that's what they call it, phase. Now, there's a problem here, and that's why I make these weird videos. You have one revolution creates one cycle, and they quite often will refer technically to each half cycle, all right, as a phase. But this service here that they're providing, and you have it in your home, is called single phase service, single phase electrical service. It doesn't make any sense. And by the time I get through my next 2 videos or so, you'll understand what I'm saying. If you have one cycle and you have 2 phases, this should be called single cycle service. But they don't do that, and I don't know why. It's really aggravating, especially when you get to electricity that's provided in what they call 3-phase service. That gets really weird and really confusing. So what I'm saying is, I don't believe there's such a thing as single-phase electric service. I believe that there is single cycle electric service. And I'll go into more detail later, but this is just a primer, just a very basic, very primitive way to show you how they get that term, single-phase electric service. It's a crappy term. And if you can bear with me in the next few videos, I will make it perfectly clear what I'm talking about, and it will make more sense, and it won't seem so primitive and stupid. So thanks for being patient, and I'll try to whip out some more videos and finish the story. Good night. Hi, I'm back. I'm technically challenged, so I'm going to try to hook these 2 sections of video together if I can. I just mentioned, all right, in one single conductor, that in 1/120th of a second, current goes this way, all right? Then in the next 120th of a second, the current goes that way, and I mentioned that they're often referred to as phase A and phase B, okay? Now, let's continue forward just a little bit. So what really is a phase, okay? A phase, by definition, is a distinguishable part in a course or cycle. It's a distinguishable part in a course or a cycle. And a cycle, of course, is a period in which something occurs. Now, well, if it's a part, then a part plus a part equals the whole, right? That's very simple. Phase A plus phase B should equal one cycle, okay? I showed you that one cycle. Phase A plus phase B, each is 1/120th of a second. You put them together and you get one cycle, one complete cycle, right? So phase A and phase B, they are parts. They're called actually action parts. I don't know if I invented that, but I've been calling them that for a while. you have two action parts that are different. They're different. They're not two of the same phases. This is very important for me when I move on to my more complicated discussion of three-phase. So when you're using the term phase in electricity, electrical service, all right, this thing that I just showed you, this thing right here, all right, this is the only application in alternating current theory in which the term phase can be used sensibly. It can be used sensibly here in single cycle service. It can be used sensibly. But from here on out, it cannot be used sensibly. And we're going to get to the really good stuff. That's the point I'm trying to make. Single cycle service should be what present day contemporary single phase service is called. Okay? Thanks for being patient, and see you soon.